All right, this unit is about circular motion. And what better way to start with circular motion than looking at a merry-go-round, a carousel from a carnival. So we have this carousel spinning in a circle. The middle pole is what it rotates around, which is called the axis. Okay, now let's think about this. We have kind of you see there's horses on the outside and horses on the inner side. Which moves faster, the inner horse or the outer horse? The answer is the outer. Why? Because it's got to cover a greater distance. Okay. The carousel, the horses on the outside have a farther distance they have to cover in the same amount of time. So they're what we call rotational or linear speed is faster on the outside. However, all objects that are going on that carousel spin at the same rate. Their rotational speed, how long it takes them to complete a circle, is the same. So the carousel, all the parts in the carousel are going with the same rotational speed, but their linear, or what's called tangential speeds, are different. The farther you get away, the more area they have to cover. Okay, so again, rotational speed is simply RPMs, rotations per minute, rotations per second. We're going to go through the formula for this in a little bit. Okay, so tangential speed runs perpendicular or tangent to the circular path. It's like if you cut off the object going in a circle, like if it was on a string, you cut the string, you let it go, the object could go in a straight line. That's your tangential speed. Okay, it depends on the distance from the center of whatever's rotating. Okay, and when tangential speed is constant, the motion is said to be a constant uniform motion. Now, notice how it says tangential speed here and not velocity. When you have uniform circular motion, it means that its rotation rate is the same, which means that it's constantly changing direction. Okay, so because it's constantly changing direction, its velocity is going to change continuously because it's constantly changing the direction that it's going. All right, so the time it takes to go around is called the period, or t. During one time interval, one circle around, the object covers what's called 2 pi times the radius, the circumference of the circle. Hopefully you remember that from math class. So just like normal speed, linear speed is distance divided by time, we can look at what's called the tangential speed's velocity is 2 pi r, the circumference of the circle, divided by the time it takes to cover that. So 2 pi times the radius of the circle times divided by the time it takes to get there is your tangential velocity. So you can see here, the bigger the radius, the faster you go. However, the bigger the period, the slower you go because you don't get around the circle as fast. All right, so just like with linear speed, change in velocity is acceleration. Same thing with circular speed. Okay, the acceleration of an object moving in a circular path and at a constant speed is due to a change in direction. Okay, that acceleration of this is called centripetal acceleration. Centripetal means center seeking or center helping. Okay, and here's the formula. So we've got centripetal acceleration is tangential velocity squared divided by the radius of the circular path. So your radius, as your radius increases, your acceleration decreases. They're inversely proportional. However, if your tangential velocity increases, your increase for acceleration is that increase squared. So when you increase your your tangential velocity, your centripetal acceleration really goes quickly. Okay, that's the rate that you change your direction that you're rotating. Okay, so again, tangential speed, a straight line speed. Okay, measured in meters per second, calculated by 2 pi radians, 2 pi times your radius divided by your period, divided by your radius, is equal to your centripetal acceleration. So acceleration, centripetal acceleration is change in direction. Okay. So centripetal is circular. Tangential is a straight line acceleration. But we're looking at our centripetal acceleration here. All right. So because this has an acceleration on it, if you think back to the last unit where we talked about an object that has a net force acting on it, accelerates, this object then has to have a centripetal force acting on it, center seeking, pulling you into the center. Like if you spin something on a string, the force keeping it on the string is that centripetal force keeping the object in a circle. Okay, so the net force keeping it in circular motion. Okay, so friction keeps the race car track in circular motion. Gravity is the centripetal force that keeps the moon in orbit. It's actually the same force that keeps the Earth in orbit around the sun. So if we look at the formula for this, so if we take centripetal acceleration from the previous slides, centripetal acceleration is tangential velocity squared divided by radius. Force, just like Newton's second law of motion here, force is mass times acceleration. So because we know centripetal acceleration, we can say that not only is force equals to mass times acceleration, but we can say the centripetal force, the center seeking force, is mass times your tangential velocity squared divided by your radius. Okay. This is the main formula you're going to need to know are these. Okay. Now, without centripetal force, your car wouldn't go around a curve. Okay. And you know this because your body, as you go around a curve, it feels like you slide to the outside of your car. What happens is you're not actually sliding to the outside of the car. You're moving in a straight line due to Newton's first law of motion that says objects with a net force of 0 will go in a straight line. Okay. So when you look at this, if the force keeping an object in a circle was stopped, it would go in a straight line because its inertia now is the only thing acting on it. Okay. And if it's near the Earth and it snaps, it's going to go at a parabolic path because gravity pulls it down. Okay, that's the end of the section 1 notes. Okay, but we're going to do a couple of math problems here. Okay, so we're going to do some practice problems here. I'm going to give you some examples, and this will help you for your video review and for the practice we're going to do in class. So the first one is, what is the velocity? Should be tangential velocity of an object traveling at a radius of 2 meters that has a period of 3 seconds. So if you look at this, so the formula goes from 2 pi r divided by t to 2 times pi times 2 meters divided by 3 seconds. So if we kind of expand this out, 2 times pi is 6.28 times 2 meters divided by 3 seconds. Okay. So I'm going to do 6.28 times 2 divided by 3, and I get about 4.2 meters per second. Okay, that's the first sample problem. Now, the next question, what is the period of an object traveling 20 meters per second with a radius of 3 meters? Okay, so our equation looks like v equals 2 pi r divided by t. V is 20 is equal to 2 pi r is 3 meters divided by t. So the first thing I'm going to do is multiply both sides by t. Okay, and then I'm left with t times 20 is equal to 2 times pi times 3 is 9.28. So then I'm going to divide both sides by 20, and I get t is equal to 9.28 meters divided by 20 meters per second, and 9.28 divided by 20 is 0.46 seconds. Okay, so there's how to do some tangential velocity problems. So let's look at some other problems here. So looking at there's some triple acceleration questions here. What is the acceleration of an object traveling at a tangential velocity of 20 meters per second with a radius of 3 meters? So we start out with the equation acceleration, centripetal acceleration is tangential velocity squared divided by the radius. Our tangential velocity is 20 meters. Our radius is 3 meters, 20 meters per second and 3 meters. So 20 squared is 400. 400 divided by 3 is 133.33 meters per second. Now if we solve for tangential velocity, because we have this problem, what is the tangential velocity of an object with a centripetal acceleration of 10 meters per second at a radius of 5 meters? So our tangential velocity, we don't know. Our centripetal acceleration is 10 meters per second squared. Our radius is 5 meters. So we're going to multiply centripetal acceleration times radius to bring radius over to the other side. Then we take the square root of the tangential velocity, so we get this. Okay. Square root of centripetal acceleration times radius, which is the square root of 10 times 5, or the square root of 50, is 7.1 meters per second. Now I'm going to leave these other questions up here and just have you take a look at them. Feel free to pause this if you want to take a look. And those are the type of math questions you are going to see on your tests and on the practice. So make sure you answer the questions on the video, and we will see you in class.